Okay, a little while back on this channel, we did the sum of 1 over n squared plus 1. This one's really similar. The only difference is just we have minus 1 to the n in the numerator here. So to start with, we'll do some similar things. I'm going to factor this denominator using complex numbers. So I can factor this thing as n plus I times n minus I. Because when you multiply it out, I squared is minus 1 with the minus sign gets back to this plus 1 right here. And in order to set this up so we can break it up into two fractions, I'm going to create the cancellation I want. So we're going to create each of these terms and add them together. So what we can do is create n plus I and subtract n minus I. The reason for doing it this way, if we split it up into two fractions, we have n plus I for the first one. And then the second one, we're going to have the n minus I here in the numerator. But then what's going to happen, the n plus i's are going to cancel and leave a 1. The n minus i's are going to cancel and leave a 1. The only thing is, you notice if you add up this numerator, what's going to happen, the n's cancel, but you end up with 2i. So then I'm not changing it. Let's divide that off up front here. And then let me just rewrite it, distributing in this minus 1 to the n to each of these fractions. Then from here, what I want to do is use this formula we have over here to the right, putting this in the form of the Digamma function. If you're not familiar with the Digamma function, I have a pretty extensive playlist on it, so I'll provide a link in the description, but you can check out the derivation of this and some other concepts with the Digamma function. So if I break this up into two separate sums, it's exactly in this form. One thing I can do maybe to make it clear, on this one, here the c value is going to be I. I can just kind of rewrite this as, I can write this as plus minus I, so we have our c value here. Then using this formula, what's going to happen, we have 1 over 2i. This first one, where the c value is minus I, it's going to become digamma minus I plus 1 over 2. Everything's going to be over 2, so we can kind of put everything together. So the second piece, c over 2, that's just going to be minus I over 2. Sorry, I got to write that in there. Then next we'll deal with this second one where our c value is going to be I. So let's write it like this. So we're subtracting these two things. We're going to have digamma c plus 1 over 2. So that's going to be I plus 1 over 2. Then minus, we're just going to have digamma of I over 2. And this is all going to be over 2 right here. And from here, what we need to do, we just need to simplify some of this digamma stuff. I can actually kind of break this up. We've got 4 terms. I can deal with them separately. Like we have, these look kind of similar. So what I can do is, when you distribute the minus sign, this becomes a positive digamma I over 2. And then here we'll have minus digamma minus I over 2. Then on this thing right here, I want to use a formula, this reduction formula. Digamma z plus 1 is going to be the same thing as digamma z plus 1 over z. And then if we rearrange this, we can write this as digamma z equal to digamma z plus 1 minus 1 over z, just subtracting this on both sides. So then for what we have for digamma I over 2 minus I over 2, if I add 1 to it, then what we have is digamma 1 minus I over 2 minus the z value is this whole thing. So it's going to be, let me just make it clear, it's going to be minus I over 2 over here. So just cleaning this thing up, what we're going to have for this value right here is going to be digamma 1 minus I over 2. Here, this is going to become a plus sign. Bring the 2 into the numerator, we have 2 over I. So then we'll plug this back in here and distribute the sign in. So we have digamma I over 2 minus this stuff. But then on this, I just want to reverse these terms, reversing the sign on it. So if I bring a minus sign out, I can write it as digamma 1 minus I over 2 minus digamma I over 2. And what that allows me to do is use the digamma reflection formula on this thing right here. So making use of this reflection formula, where the z value on it is going to be just this I over 2, what's going to happen is we still have the minus sign out front, plug in, we have pi, cotangent, pi, plug in I over 2 here, and then we still have this minus 2 over I here. On this 2 over I, let's just kind of multiply in I over I, so that way this becomes a minus 1 that I can use to make this a plus. On this thing right here, cotangent pi I over 2, we can use a formula on that. Let's just take a look at that really quick. We have these two formulas for cosine Ix and sine Ix to convert it into hyperbolic cosine and hyperbolic sine. Putting that together for cotangent, we get minus I hyperbolic cotangent of just x. So what's going to happen here when we do this, let's see, we distributed the minus sign, so we're going to have minus pi. Then using this formula on this, where I could actually write this to get it exactly in this form, think about it like I times pi over 2, so like pi over 2 is going to be the x value. Then for this we have minus I hyperbolic cotangent, the input, pi over 2, and we still have this plus 2i here. So putting this all together, multiplying minus times minus is going to be plus, we get just I pi hyperbolic cotangent pi over 2 plus 2i. And we'll just make a note of this value because we're going to use it for this thing right here. Okay, so we've captured half of what we need right here. Now we're on to what's left, this expression right here, which looks a little messy at first, but just notice we can rewrite this, especially this first piece. How I can write this to make this work is I can write it as 1 minus this thing. Just notice if you break this up, you have 1 minus I over 2, then minus a half. But 1 minus a half is just a half minus I over 2, 1 minus I over 2, which is exactly the same as this. So it's just kind of a different way to write it. But the reason I do it that way is when we bring this in, now we can use the reflection formula again, the same thing we just did on the other board. The only difference here is now our z value is going to be a little more complicated. It's just all this. But then we just apply the formula. It's going to be pi cotangent pi times z, our input, which is just going to be I plus 1 over 2. Then here what I can do, we can just we can simplify this, just distributing in the pi. So the way I can write it is pi times cotangent, let's see, like I pi over 2, distributing the pi in here, we can have this as pi times a half or just pi over 2. But then writing it this way, we can just use a complementary angle formula on this. What we have is for cotangent pi over 2, this is going to be the same thing as minus tan x. So using this, what's going to happen is now we're going to have a minus sign in front, minus pi tan of this thing, which is just I pi over 2. Then doing basically the same thing we did with cotangent. With cotangent, we said, what did we say? We said cotangent Ix was equal to minus I hyperbolic cotangent of x. So now with tan Ix, just flipping this whole thing, what's going to happen is this becomes I times tanh of x. So plugging that in here where our x value is going to be pi over 2, what we end up with is just going to be minus I pi hyperbolic tangent of just pi over 2. And so now all we need to do is we need to take this value and add it with this right here, and that's going to be this whole numerator right here. So let's see how that's going to look. Okay, we're making some good progress, but we need more simplification. So, hey, one thing I notice is these i's are going to cancel everywhere throughout here. I think next let's deal with the hyperbolic cotangent, hyperbolic tangent. And I don't really care about the pi over 2 yet. I'm just going to look at what happens. We can factor a pi out of these, and what we're looking at is hyperbolic cotangent of x, tanh of x. And actually, let me just let's forget about the pi. We can deal with that afterward. But for this isn't bad because what we have is reciprocals. I can break this out. I can break this down into sines and cosines, or sinches and coshes. So this is going to be cosh over sinh minus sinh over cosh. But then if I get a common denominator on this, what's going to happen is we end up with multiplying in like cosh over cosh here. We get cosh squared of x, sinh over sinh here. Then we're going to have sinh squared x. And then this denominator is just going to become sinh x, cosh x. Well, I'm out of space. Let me bring it back over in this direction. So for cosh squared x minus sinh squared x, we have an identity for that. That's just going to be 1. And then this denominator looks a lot like our double angle formula for sinh, which is the same as like our sine formula. So what I'm trying to do is, let me just multiply in 2 on both these numerator and denominator. So I'm just multiplying by 1 and write it as sinh x, cosh x. But then what's going to happen here, we'll write this a different way. We'll have 2, and then using that double angle formula, this is going to be just sinh of 2x. So we'll use this and try to clean up all of this mess. What's going to happen, we still have this big 1/2 in front. From these two terms, let's factor out the pi like I said before. And then for our hyperbolic cotangent, hyperbolic tan, we've got this thing. So we'll just kind of plug that in. It's going to be 2 over sinh of 2, but our x value is this pi over 2. I just kind of left that off to simplify it. So we have 2 times the x pi over 2 here. And then we still have this plus 2 hanging around. So we have that, and it's all over 2. But now I think it's a good time to distribute in this 1/2, as I can cancel 2 with 2 here, just leaving a 1 on that, and cancel a 2 here to give a 1 right here. And then one more thing, I can also cancel these 2's here, so the input's just going to be pi. So I think we can put it all together for the final solution. So what we're left with is going to be pi over 2 sinh of pi plus 1 over 2, and that's it. And alternatively, if you wanted to convert this into exponentials, you could write your solution a different way, something like 1/2 plus pi over e pi minus e minus pi. And that's basically just as compact, so not bad. Interesting problem, kind of a bit of work doing that. I do have some other ways, I don't know if they're easier, but there are multiple ways to do it. So I don't know, maybe in an upcoming video, we'll do this a different way. Okay, that's it for today. Thanks everyone for watching. Have a good day.